There we go. The recording has started. So if you're out in video land, we've just taken time to try all the questions on this page. So as you look at this question, you could take a moment to try it. Stop the video and then restart it when you're done the question. For us who are in the room, you already did question number 1. Who can help me? Well, lots of you can help me. You don't have a mic on, so you probably won't be heard, and that's okay. Unless you really want to be heard, I could give you a mic. Should I get the microphone? Oh, I should get it just in case. There we go. So you could use this microphone. Lots of air noise. Oh well. Volunteer without the microphone. Boy, at this rate, this is going to be a really long video. Okay, I'm going to pick somebody like Roshan.
So, I did long division.
Excellent idea doing long division, thank you.
And then I found everything out.
Oh, but how do you do long division? That's what I'm trying to figure out. So
I look at the first number,
like
it's a 2, but I can't divide 13 by 2.
Oh, 13 doesn't go into 2.
Placeholder 0 there.
Oh, you put a placeholder 0 up there. Okay, that's optional, but we can do that.
Yeah. And then I look at 27,
Uh-huh.
and you can multiply 13 by 2, so it's 26. And that's
So
so you go above 27.
13 times 2 is 26, and we put that 26 under here.
Yeah.
You need to make sure it's less than the 27. Okay, then
And then you subtract.
Subtract, and we get 1.
And then you gotta bring down the 4.
Bring down the 4.
And then you can only put 13 once.
Goes into 14 once.
You subtract 14 by 13.
Oh, and where does that 13 come from?
You like multiply.
Oh, I have this 1 up here for people at home, times that 13 there, which gives me a 13 here. Oh, yeah. Okay, which is 1 again.
You gotta bring down the 8.
Bring down the 8.
And now it's 1 again.
1, and then 1 times 13 is 13. And you get 5. And this is called remainder. Thank you. So there's the remainder. And at the very top, it said we want this dividend equals divisor times quotient plus remainder. So we figured out remainder. The next easiest is probably the quotient. And the quotient is what we have at the top here. So quotient. Anybody know which is the divisor and the dividend? Nobody wants to tell me anyhow. Okay, so this one over here, this is the divisor. Oh, I'll just do this. That is the divisor. And this number there is the dividend. Dividend, not a term that you need to remember. Divisor, quotient, remainder, all of those are likely to show up, especially quotient and remainder, but divisor is also useful to remember. So a divisor is what we're dividing by. So we're asked to write it in that form. But before we get to that, I want to talk about why that gives us a true relationship between these 4 numbers. So let's think about an improper fraction, like 48/5. Improper fraction. If I want to change that to a mixed number, what would that equivalent mixed number look like? Oh, got to practice names here. Muhammad. 9 3/5. And how do we get that? Okay, count by 5s to get up to 48. We can get to 45. So there are 9 complete 5s. So that's the whole number part, but then I have 3 left over from the numerator. So as we look at this, this is like the 9 is my quotient, the 3 is my remainder, and the 5 is my divisor. And the 48 would be my dividend. So if I were to write dividend over divisor, then I get quotient. Ooh, what's the unwritten operation between the 9 and the 3/5? Carter. Addition, yeah, which is a little weird because if I had 2x, what's the invisible operation between those two? What? Multiplication, yeah. So here, if I have a mixed number, there's an addition sign that's implied in between, whereas over there with the 2x, multiplication is implied. Okay, so if I were to take this equation that we have up there, and I multiply both sides by the divisor, what happens? Well, here the 5's cancel out. I get 48 is equal to 5 times 9, which would be 45. I'm not going to expand it. And then the 3/5 times 5, the 5's cancel, and I get 3. This is dividend equals divisor times quotient plus remainder. So both of these statements, the one in black and the one in green, give us a true relationship between those 4 elements, dividend, divisor, quotient, remainder. But more often, we'll be asked for the one in green. Not always. Sometimes you just ask what's the quotient or what's the remainder. In this case, we're asked to write it in this form. So I'm going to say my dividend from the original question, 2,748, equals my divisor, which is 13, times my quotient, 211, plus the remainder of 5. If we expanded the right-hand side, like did the multiplying and adding, we would get 2,748. Good? Question number 2. How is this similar to question number 1? Since you've all been so quiet, I think I need to pick on somebody like Isaac. Isaac, what would you say? How is this similar to number 1? Yeah, so it's the same numbers. We've just shown the base 10s, where in the first question, we just used place value to tell us the 8 is 1, the 4 is how many 10s, the 7 is how many hundreds, or 10 squareds, and the 2 is how many thousands, or 10 cubes. So yesterday we talked briefly about our number system, which is base 10, and we used place value to tell us how it's multiplied to a power with a base of 10. So same question. Number 3, if I was to ask how is this one similar or different to number 2, then what would Nathan tell me?
It's sort of the same, except in the place of power of 10, they have x.
Yeah, it's the same, but instead of having the bases of 10, we have bases that are x. This is one of the uses of polynomial division, where we can imagine that this is some number with a mystery base. Yesterday we talked about numbers in base 2, or binary, and we talked about numbers base 10. We could have a number with a base of 60, like the Babylonians did in ancient times, where they would have basically a base 60 number system. You'd have to have 60 different digits or symbols to represent that number system. I imagine it was fairly complex. When we do this division, it's similar but slightly different. So what we'll do as we do this division is, instead of saying, oh, the x plus 3, how many times is that going to 2x cubed? And we say, well, it doesn't, because it's a binomial into a monomial. And then we'd extend it to those two. We don't do that. Instead, all we do is we look at just the first terms. So I'm just going to look at this x and the 2x cubed. And I'll say, how many times does x go into 2x cubed? Or what's 2x cubed divided by x? And you would say 2x squared. Yes. So I'm going to put 2x squared above my 7x squared because, again, I'm aligning the same or the like terms. Ooh, pardon me for a moment. All right. So we have the 2x squared. And now, so that was slightly different than long division with just numbers. But now it's exactly the same. I'm going to take that 2x squared times this entire binomial. So 2x squared times x, 2x cubed. It should be identical to the term above. Otherwise, we've made a mistake if they're not exactly the same. 2x squared times 3, 6x squared. And then again, just like long division, we'll subtract. The first two terms cancel out, the cubic term, and then 7x squared minus 6x squared, 1x squared. And then, just like Roshan helped me with earlier, we bring down that 4x. It's positive, so we bring the sign in front of it with it. And then I start over again. X into x squared, or x squared divided by x, gives me just an x. So I'll multiply that x, that's blue part of my quotient, times this entire divisor again, which will give me x squared plus 3x. And again, subtract. X squareds cancel out. Perfect. That's what I want to see. 4x minus 3x is just x. Bring down the 8. And repeat. X goes into x one time. Multiply that to the divisor, and I get x plus 3. Subtract, and I get 5 as the remainder. So very similar to our first answer, but now we have x's in our polynomial. And so I can write out my dividend, 2x cubed plus 7 x squared plus 4x plus 8 equals divisor x plus 3. Remember the brackets? Because all of this is going to be multiplied to our quotient, which was, there at the top, 2x squared plus x plus 1, and then add our remainder at the end. Take a moment, check in with your neighbor, see if they have any questions about this process. So, because I want to demonstrate that we could have a polynomial with negatives in it as well. So suppose instead our question was, let's say 2x minus 1 into, let's say 6x cubed minus, nope, we'll do plus 8x, no. Yeah, sure, 8x squared minus 3x plus 4. So suppose we had that. So what we would do is we'd look at this term and say 2x squared, how many times does it go into 6x cubed? Or what's 6x cubed divided by 2x squared? So 6 divided by 2, 3. X cubed divided by x, x squared. So it's going to be above this x squared term, and my coefficient will be a 3. Does that make sense? That's how we're getting that first term. Then this gets multiplied to this entire binomial at the front. The 6x cubed, 3 times 2 is 6. X squared times x, x cubed. And then times this negative 1 gives me a negative 3x squared. And here's where it's a little tricky, because when we subtract, these first two terms will cancel out, but then I'm doing 8x squared minus a negative 3x squared, which is actually adding, all right, because I'm subtracting that whole thing. So that'll give me 11x squared. And then I bring down the next term, negative 3x, and we continue, this is going to get awkward because now I'm saying, oh, 11x squared divided by 2x, I'm going to have a fraction. That's beyond what we need for this course, so I'm not going to keep going with this question. But your workbook will occasionally give you a question where you're dividing by a binomial where this coefficient is not necessarily 1. That's beyond what's required for the course, but your workbook has some questions like that. If you ever see it, long division is the way to go, and they should have, I think, set it up so that you're not going to have this problem of getting fractions in there. We could do it, and if you want to challenge yourself, you should try some of those, but it's beyond what we need for this course. Is that good? Any other questions? Nope. We're going to look at a different way of doing division. So we have the same polynomial, same divisor, but we're going to look at this strategy called synthetic division. Synthetic division only works for dividing a polynomial by a binomial that's degree 1. And it's best if this binomial has a coefficient of 1 in front of the x. If it has any other coefficient, then there's some adjusting we need to do to our answer to get the answer actually correct. But for this course, we're only expected to be able to divide by polynomials that are degree 1 and the coefficient is 1. So synthetic division will always work for what's required in this course. Workbook occasionally goes beyond this, and the assignment may go beyond this as well. And in fact, I think on the next page, I give you an example or a question to try. Here where you're dividing by the 3x minus 2, always do long division if you have something like this show up. This is beyond what's required for the course, but I thought throw in a bit of challenge in that check your understanding question. So synthetic division, here's how it works. Oh, just before I do this, I want to go back to this previous page and say, let's say we look at this question. Sometimes what we'll do as mathematicians to be more efficient is we'll leave off the variables. And we'll have the 2 and the negative 1 leaving out the x, and then a 6 and 8, negative 3 and 4. And we space them out a little bit so we can see there's not 8 subtract 3, but that this negative 3 is a separate term. And then just like with the number at the top of this page, we didn't put the powers base 10 in. We did in number 2, but we typically wouldn't because we understand there are 8 ones, 4 tens, 700s just from place value because we understand that. With polynomials, we can do the same thing where I'd say this 4 is my degree 0 term, so it's my constant. This is my x to the 1 term, this is my x squared term, and x cubed term. So as we go from right to left, we just increase the degree of the exponent. We don't write it in just to be more efficient, but the process would be the same where I would look at just the first term. 2 goes into 6. How many times? 3 times, so I put it over that next number. 3 times 2 is 6, 3 times negative 1, negative 3, and again subtract, and I would get 11. Just like I did up there when the variable was in the equation. This just makes it a little more efficient. There's not as much stuff to write down. Do you have to do that? No. But I show it to you because synthetic division does that. It leaves out the variables. So we would take these coefficients, the 2, that doesn't look like a 2. Let's try this 2x cubed, and then the 7x squared, 4x, and 8. So we write out the coefficients without any of the variables. It's kind of like there are place values telling us what the variable would be with it. Then there are a couple notations. For this one, I'll do a notation that looks like this. And I'm dividing by x plus 3. So I look at this and say, well, what value for x would make that 0? And you would say x equals -3. So that -3 we put out on that side. Then the first number we just bring down. In a little while, I'll talk about why that works. For now, we'll just bring it down. And we do, oh, put your pencils down for a moment. Just look while I write this up, and then I'll stop and give you time to write it down. Okay? I'll do -3 times 2, -6. Unlike long division, I'm going to add instead of subtracting. 7 plus -6 is 1. 3 times -1, -3. Add is 1. 3 times -1, -3. Add is 5. Before you write anything down, look at these numbers, and then look at the previous page, the answer for number 3. How are they similar? Who can tell me? Yes. The numbers are the same. So as in this 5 is what? 5 is the remainder. So in this spot, we'll see the remainder. And then those numbers are what? Coefficients for the quotient. So in order to write this out, I start at the right and say I have one constant, and then I have 1x, and then I have 2x squareds. So it's again using that idea of place value, working from right to left, increasing the degree of my variable. So I'm close to out of space, but I'll fill this in. So there's my quotient. My divisor was x plus 3. Make sure it's in brackets, plus my remainder, which is 5. This equals my original polynomial, 2x cubed plus 7x squared plus 4x plus 8. And I stop and give you time to write. Try number 6. Okay, first of all, you'll notice I set this up looking slightly different. This is a variation of the notation. Either way is fine. Multiple ways of showing the work. But I started by writing out the coefficients for the dividend, what I'm dividing into, and the negative signs we make sure we put in there. Then how do we start? First step is, oh, yeah, what haven't I filled in that I need? You're so secretive. You just don't want to tell me anything. Well, it'll come. We want to say, oh, what value for x makes that 0? And you can shout it out this time. X equals 2. That's not quite a shout, but I'll take it. So the 2 goes there. Next. Do what? Bring down the 3. Why? The reason why is because when we use synthetic division, we will only use it when this coefficient is 1. So if I divide 1x into this first term, 3x squared, what will the coefficient be? 3. So because I'm dividing 1 into this coefficient, whatever that coefficient is will be the first term in my quotient. So that's why we can just bring it down. Then we'll multiply 2 times 3, 6, and add, giving me -1. 2 times -1, -2. Add to give me -6. 2 times -6 is -12. Add to get -4. Is that what you got? Seeing a few nods. Good. And again, now we can just write out our division statement. 3x cubed minus 7x squared minus 4x plus 8 equals divisor x minus 2 times the quotient 3x squared minus x minus 6. So again, as I look at these terms, I think of this is my x to the 0 term, x to the 1 term, x squared term. And those are the coefficients that go with each of those terms. And then my remainder, minus 4. Good. Any questions? No questions. So we'll add a little bit of challenge. As we get to the next question, this time our polynomial is written in a different order. What we want to do is make sure that whatever order we have for the terms in the numerator is the same as in the denominator. In other words, right now the numerator has ascending powers of x, like it starts with a constant and then goes up to the x to the 4th. But the denominator goes the opposite way, descending powers of x, x to the 1, and then the constant term. We want to make sure they're both the same. Either way works, but just to make life simpler, it's not a bad idea for us to always write it in descending powers, x. There we go. So I'm going to rewrite it descending powers of x, but just before I do that, if I was going to write down 2076, is that 2076? No, but I have the 2 and I have the 76. What's missing? Missing is 0. Why do I need a 0? Because why? What? Yes. I need a place value. So I have 2,000, 0 hundreds, and then 7 tens and 6 ones. So we're going to do the same thing with our numerator. We'll say I have 1x to the 4th. How many x cubed? 0x cubed. How many x squareds? Negative 13x squareds. How many x's? 0 x's. How many ones? Negative 50. So just like with this number, in order for it to mean 2076, I need a 0 placeholder. With this polynomial, I need 0 placeholders for those terms that are missing in the polynomial. So if we do that, and maybe I'll just add in that we've rearranged this to x to the 4th minus 13x squared minus 50. So put it in descending order. I'd like you to finish off the question. I'm seeing a number of people getting a remainder of negative 2. So if you're getting that, you're probably right. If you're not getting that, you might want to double check your work. There's my answer on the board. Anybody have a question? Yes. Well, as we go through this process, these numbers get added. Yep. And those will be added as well. There's a variation of synthetic division where you subtract, but what we would do then is we would say, oh, that's a negative 4, so we'd put a negative 4 here. That method works, but this positive 4 is a really useful number for us to use, and we're going to learn about why in tomorrow's lesson. So that's why I teach this variation of synthetic division. Yes? For the dividend, this order It doesn't matter as long as it's equivalent. So I chose to put it in this order. If you put it in the original order, that's correct. Nothing wrong with that. Yes? As in the long division? So you're expected to know both long division and synthetic division. Long division, because it's connected to things you've previously done, we didn't spend as much time on it. But this one, because it's new, we spent a little more time on it. So when we get to the next page, which we won't jump to just yet, but I'll just show you. The first question, I say synthetic division. Second question, ooh, kind of tricky. I'll give you a hint. You'll factor the denominator first. Then you'll divide the numerator by one of the factors in the denominator, and then the quotient by the other factor. Okay, this one's set up so that it actually goes in evenly. There shouldn't be a remainder. And then the last one, because we're dividing by the 3x minus 2, I'm suggesting do long division. So we'll review it when we get there. But just before we get to this page, at the bottom of the page we just finished, just some terminology to help you remember. This form, this is dividend equals divisor times quotient plus remainder. So the p of x is our dividend. It's the original polynomial that we're dividing into. What's required by Alberta Ed for 30-1 is that our divisors will always be of this form, x minus a number. Again, in the workbook, it may not look like this, or on an assignment, we may go a little more challenging. Test, quiz, diploma exam, cumulative, whatever, they will always be in this form, x minus a number or plus a number. So that is our divisor. The q of x will be our remainder. And again, we use function notation because typically it's a polynomial with x's in it. And because we're dividing by a degree 1 binomial, a linear expression, our remainder will always be a constant if there is a remainder. It's possible to do division of polynomials where the remainder is a polynomial, but again, that's beyond what's required for the course. Once you have this written down, before you look ahead to the next page, imagine it's October 16th. Tomorrow is the cumulative exam. As you look back over this page, what might you have forgotten that hasn't been written down? In other words, is there something that's a good idea to add to your notes now so that your future self will have that reminder? Look back over your notes. What might you need to add? Once you've done that, then try to check your understanding on the next page. I'm going to interrupt you just for a moment. How do you know if you have the right answer? Well, that's where this, it's called a division statement. I guess I should write up here so people in video land know what I'm talking about. This is called a division statement. Often you're not asked to write that out. But if this has to be true, you could just multiply the right-hand side out and then add in the remainder, see if you get the same polynomial that you have on the left. So you can actually expand it out to check to see if your answer is right. You may continue. There's what I got for number 8. Number 9 and 10, I will, after you leave, I'll add them to the video, but we can look at them tomorrow.